Okay, so there are some things that we want you to think about when we look at this matching exercise, and that's, we have more familiarity with graphing exponentials, so these two should be more in our wheelhouse, and then these are new. So let's do what we know a little bit more first. Like this one, for example, we've been doing the most. We know it's increasing because the base is more than 1. It's increasing as it's going from left to right, and the asymptote is at y equals 0, so it's approaching the y or the x-axis. So this one here is the one that's approaching the x-axis, and as you go from left to right, as you increase the input, it's getting further away from the asymptote. So the original graph is graph C. And we'll talk about what the inverse graph would be in just a second. But let's do the originals first. And for this one here, it's decreasing, and more specifically, it's kind of diminishing toward the asymptote is a better way of looking at that. So because it's not always going to be decreasing if there's a negative out in front. So diminishing toward the asymptote, again with an exponential, it's going to be approaching the x-axis unless it's been shifted one up or down. And so this one here is diminishing toward the x-axis. Now that means that the inverse is probably going to be one of these other two. Okay, so if we can find the inverse of this one, we can kind of recognize, I would hope we can maybe recognize the inverse of this one, because the base is 2. This one has a base of 2 here. So just a quick reminder here, when we switch x and y to find the inverse, we have x is equal to 2 to the y power. The only way of getting that y down from its perch there is to change this into a logarithm. And so we write it as a log with a base of 2, because that's our base. Log base 2 of x is equal to y. That is the inverse of that equation, because we first switched x and y and then rewrote it solving for y. That equation is that equation. So what we can do is, since this original was c, then this guy's inverse is actually c. Okay, and same thing with this 1/2. There's your base. There's your base. Same thing applies. This inverse here happens to be d, because this equation is the inverse of that equation. So how do we graph it? Well, if we go back to describe how this thing is graphed, as it's moving in the positive direction, as x's inputs are increasing, it's peeling away from the asymptote. Okay, so it's inverse. This one here, if you switch x and y, then you just switch the x and y, and even in your explanation, as this thing is increasing its input of y, then it's going to be peeling away from the asymptote. So if this one's going in the positive direction, it is peeling away from the asymptote in that way, and the asymptote is a vertical asymptote as opposed to the horizontal asymptote here. So that is in fact the inverse of this one. So the inverse would be the a here, but that's also the graph of the logarithm there. That's one way of explaining it. There are other ways of explaining it. This one here is, as you increase the input, it's diminishing toward the asymptote, and so that one here is b, and the inverse of that one would be over here.